After selecting the front view, the other object views are based on that selection. Let's apply this skill to real objects. Take an airplane, for example. The profile view of the aircraft that meets the criteria of front view selection becomes the front view of our drawing. The top-down view of the aircraft remains the top view in our drawing location. The nose-on view of the aircraft becomes our side view. Each of the views interacts with the other views. The front view has the same height as the right side or left side view. It also has the same length as the top view. The right side and top views share the same width of the part. When do you choose a left view instead of a right side view? Remember that when selecting the complementary views in a multi-view drawing, you need to look at the amount of detail and the number of hidden lines. So, if the left side view shows more detail and has fewer lines than the right, use the left view. The space between the views is also a decision that's made by the designer, but the distance is typically no smaller than 1.5 inches. When arced surfaces are involved, they will appear rounded in one view, and in the orthographic view, they will appear similar to a flat surface. Knowing how to interpret images like this is one of the hardest skills to master in multi-view drawings. For example, when you have a hole drilled on an angled surface, the hole will look elliptical on a plan view. To create this shape, you need to project the position of the hole from the angled surface. To project the hole, begin with the major axis positions and then project intermediate positions for the elliptical shape.